Hello, can everyone hear me? Yes? Okay, cool. Right, so welcome to this little mini session. In today's 20-minute session, we're going to be looking into the high-definition render pipeline and how it will unlock games for you. I'm incredibly excited to be here, actually. I've done a couple of talks before, so this is going to be one of the smaller talks that I've done, but I hope everyone's having a good second and a bit day, isn't it? Yeah. Okay, so I feel like I should give a bit of an introduction to who I am personally. So my name is Kieran, and I'm one of the art evangelists for Unity, and I've been working for Unity for around about a year. So if you see any of the evangelists roaming around, please say hi, please talk to us. We would love to chat to you about Unity and all things technology. And it's our job as evangelists to travel around, go to conferences, go to events, but I think most importantly to interact with you guys, the amazing Unity community as such. But today's agenda, we're going to be looking at what is a pipeline and what can be found in the high-definition render pipeline, the fundamentals of HDRP, and then we'll do a Unity demo with an introduction, the basics of it, and then we'll create a refracting glass material, which was notoriously difficult a few years ago to achieve, but now can be very easy with the pipeline. So when I started Unity, I have to admit, I didn't really know what a pipeline was. I kind of went in, and it was spoken about internally for a couple of months. And I remember asking myself two definitive questions. The first one was, what are they, and what do they actually do? So how do they benefit me as a developer? So a render pipeline, in general terms, is the number of techniques used to get an object onto a screen. And it roughly encompasses rendering, or culling, rendering objects, and post-processing. And of course, these can be kind of subdivided into their own unique categories. And in 2018.1, we introduced a system called the scriptable render pipeline, better known as SRP. And with the scriptable render pipeline, you are able to customize what you require graphically of the Unity engine. So with SRP came two ready-made pipelines. The first one, originally called Lightweight, but now is called the Universal Render Pipeline, is performance-focused and works on most platforms, whether you're developing from mobile all the way up to high-end devices. And then we have the High-Definition Render Pipeline, which in 2019.3 is now officially out of preview, and is more graphical-focused and is more suitable for platforms with which can handle more intense graphical processing. So PCs to, consoles to high-end PCs, pretty much. Okay, yes. I don't know if any of you have seen The Heretic before. Hands up who has seen The Heretic? Oh, okay, a few of you. So earlier this year in San Francisco, we actually released our first part of The Heretic, Part 1, and that actually uses a whole load of HDRP features that you are free to use. And most recently, a couple of days ago, at our keynote here in Copenhagen, we released the second Heretic demo, which demonstrated the same fundamental principles. The image in the middle is actually the London demo, which I'm going to be showing you today. And this is a visualization of our office demo. And I want to kind of show you how you can kind of graphically make a scene look great, both for cinematics, such as The Heretic, and also for games as well. And on the far right, has anyone seen this image before on the far right? Okay, one person, yeah. So this is Sherman. So this was a short film that we released a couple of months back, which demonstrated how short films can actually be animated and made in Unity, again, using the pipeline. So you can see 3 different use cases with 3 different outputs, and yet using the same technology. So I wanted to bring up some points. So these are some things that I think are interesting from an artist perspective. Most importantly is the shader library, in my opinion. So we have subsurface scattering, anisotropic materials, iridescence, transparency, decals, and layered lit, or a layered lit shader. And I'm going to go over a few of those today. We have a sky, so these are the new things that are in it. So a HDRI sky. For any of you that don't know what that is just a cube map, which is a collection of 6 images that represent different directions in world space. And then, of course, the procedural sky, and then our gradient sky. Lights and volumes. So we have physical light units. Now, this is quite an interesting one. I'm not going to go too much into it now, but I will in the demo, because for any of you that are wanting to achieve as realistic visuals as possible, this may be right up your alley. And then our volume component, which controls everything to do with graphics and shadows and all of that. And then finally, in 19.2, we actually have native post-processing. So it's actually part of the HDRP package now and can be integrated using the same volume component. And then finally, we have rendering. So, of course, the HDRP is a hybrid of deferred and forward cluster rendering. And most importantly, we have a thing called HD render pipeline assets. And these are assets that allow you to control what you require graphically of our engine. So I wanted to just spend some time to go over some of the default, the default material inspector, because I think there's quite a difference between the left and the right. So the left is HDRP, and the right is just a built-in. So the difference being that we have a section called surface options at the top, which is allowing to determine the material surface, whether that's transparent or opaque. And there are different use cases for that. Of course, we have double-sided, and we also have displacement mode. And this is I like this one a lot. I'm going to go into the demo for this. But this allows you to kind of deform the pixels according to a particular texture, a particular height map, and that's used for a carpet in the scene. Then we have a mask map, which is basically a hybrid or a collection of textures all brought into one, so including metallic and smoothness. We have a coat mask, and then we finally have a detailed map. Now, for any of you that have used Substance Painter or Substance Designer, Substance Painter now comes equipped with a preset that allows you to export out textures specifically for HDRP. So if you're interested in kind of generating these maps, you can just do that through the export texture section. And then with HDRP, we kind of advise that it's best for you to start using it at the design tech select stage, so at the start of your project through Unity Hub. But there is nothing stopping you from actually upgrading, there's nothing stopping you from upgrading the projects midway. Let's say your prototype stage through our package manager. However, this would require a little bit of work, so fair warning. So we actually encourage you and advise you, if you want to start learning this stuff, to start from scratch. So let's actually check this out. So it might be a familiar site to some of you. It might not. But this is our London demo. And this was created by a company called Oneros. And Oneros, we contacted them, and it was a collaborative effort to make a scale model of our London office demo, of course. And we actually have 2 other demos for this as well, both in Tokyo and in Korea. But because I'm British, I have a bit of a soft spot for the London demo. So I'm going to show you this one today. So I can fully look around. I can fully navigate my scene, and I can have a little look around and waltz around. And you can see it's quite a nice-looking scene already. And I want to pick it apart and show you what each element is made of and why we've been able to achieve this. So the first thing, let's imagine that we've opened the project, and this is in built-in, not in HDRP. What would be the steps to upgrade our project? Well, the first thing would be to go to what's called our package manager. And to access package manager, you go up to Window and Package Manager. And in here, you can see I've already got the high-definition render pipeline installed, but you would just simply install this. And if it doesn't show up on any Unity versions lower than 2019.2, you just want to go to Advanced and say Show Preview Packages. And what that does is once we find it, wherever it is, there we go, it also includes both the render pipeline core, shader graph, and as also, of course, post-processing. So once you've done that, then you need to tell Unity, OK, what graphics do I want to render? What am I going to render, and how am I going to customize it? And that's all done within the HD render pipeline asset. So the asset can be created in a project folder. You can simply just right-click, go to Create Rendering, and then Create Rendering High-Definition Render Pipeline Asset. But I've already created one. And then to assign it, you want to go to Edit, Project Settings, Graphics, and you can see that I've got an asset up here. And now by interacting with it, here we go. You can see that I have a load of different parameters that I can start to customize what I'm requiring graphically. So this includes reflections, this includes lighting, rendering, and all sorts of things that I can kind of start to pick and choose what I want. Now, the beauty of this being an asset is the fact that I can swap this in and out, which means that I can have a certain asset that caters for a certain device or certain capabilities, and then as I work my way through different builds, I can then swap them out to cater for lower graphics or lower resolution. So it's very flexible in that regard. OK, so once we've done that, let's now imagine that I've got an empty scene, and I want to integrate an asset or some kind of mesh or some kind of package. And a natural instinct, for me at least, is to go to the asset store. And when you go into the asset store, at the moment, most of our packages aren't really compatible with HDRP, other than the ones that are being created for the pipeline. So what's going to happen is if I remove my chair here, once you import your package, you're going to get something that looks a little bit like this. And this is basically indicating to me that I have a broken shader. So the shader that the store is using, as you can see on the far right-hand side, is actually using the standard shader. So this is the legacy shader that can be found in the built-in pipeline. So the way that we fix this, of course, is to upgrade it. And luckily, we're not going to make you go through all of your assets and upgrade every single shader. So we actually implemented a tool that will do it roughly for us. And we can access that by going to Edit, a render pipeline, upgrade project materials to high-definition materials. Now, this isn't perfect. It's not the perfect solution, but it does a very, very good job at sifting through our materials and upgrading them the best it can. But of course, it's always good to kind of sift through the materials anyway to see if there are any reoccurring errors. Great. So now I'm going to bring that one back. OK. So once we've done that, then we can start to dive into our materials and start to edit our materials in whatever way we choose. So I'm going to spend some time working my way through the material inspector just to show you what you can do with it and why you would want to use it. So of course, we have our surface options. We have our material type, which we've gone through before. So standard, subsurface scattering. Does anyone know what subsurface scattering is, roughly? Oh, can someone shout out at me? Sorry? So light reflected through the, exactly. So if any of you have shone a light, like a torch through your finger, even though the light is white, it appears red, and that's because the light's bouncing around. And that's what we're able to achieve with this material type. So exactly what the gentleman said at the back, like light going through the ear. Anisotropic, so think of like jumbled up metal, like aluminium or aluminum if you're American. Iridescent, specular, and then translucent. Now, my favorite parameter ever is displacement mode, because it absolutely blows my mind how we're able to achieve this. So displacement mode, as I mentioned before, deforms the pixels according to a texture. And a really good example of this is our carpet. So notice that our carpet is like ever so slightly fuzzy, and that's because we're deforming the pixels. So if we were to interact with my material, we can see that we've set the displacement mode to pixel. We've gone ahead and added an albedo texture map, so a basic texture map, a mask map, a normal map, and then we've also got an additional parameter now called height map. And that has a parameter at the bottom, which is called amplitude. And amplitude is basically just how far am I deforming these pixels. So as I start to warp it, you'll notice it gets a little more strange and a little more strange. So be careful with this. Of course, we've set ours to kind of something minimal, so 0.5, and it's given us a little bit more detail to our carpet. OK, and then after that, I think we're going to move on to lighting. So lighting in HDRP uses what's called physical light units. And these units are basically based off real-world measurable values, similar to what you would see if you were browsing through a store, like shopping for a light bulb, for example. So for our directional light, so our sun, we're going to be using an intensity value called lux. And lux, the reason why we use lux is because that's what we use to measure sunlight in real life. And the same applies for our smaller lights, like our point lights and our line lights, which use lumens and candela. And the reason why we're using all these intensity values is because I can easily go online and find out, OK, what's the typical lux value for an overcast day? And I'm going to get the same output in Unity. So if you're a manufacturer or if you're working on design visualizations, for example, and you wanted to make sure that a bulb was exactly what the manufacturer wants, you would ask them for a lux value, and then you can add what's called a cookie or a Q-colorist. And think of it like a texture that masks out particular light, depending on whether it's white or dark, and then you'll be able to get some character to your light, which will basically mimic what those manufacturing bulbs might look like. So I'm going to increase my gizmos ever so slightly. And if I click on my light, we can see now the light inspector's ever so slightly changed as well. This time, we've actually got a temperature gauge. So we're ranging it from 0 to 20,000 kelvins. So the redder the cooler the light, the redder it is. And then the hotter the light, the bluer it is. So we're able to accurately determine it through temperature. And then, of course, here you can see, if I zoom in, we have lumens. So we've got ours currently set to 20,000 lumens. So we know that a 20,000 lumen bulb will look exactly the same in Unity as it would in real life. And then, of course, down here we have our little cookie. And the cookie, like I said, is just a texture. You can find them online quite easily. And they're pretty good to add to some lights if you want a little bit of character. And then finally, we can go into our reflections. So here we have a reflection probe. Does anyone know what this does in my scene? Yes, sir? Yeah. Exactly. So the gentleman said reflecting the surroundings. So this orb that we're looking at here is basically sampling our light or sampling the geometry around it, as you can see in the reflection. And these reflections are basically going to be applied to any object that has a specular or metallic value. As you can see on the kitchen behind, you can see that it's reflecting our window. If I were to completely remove my reflection probe, those reflections just aren't accurate. They're just not, we're getting a little bit, but it's not as nice. And if I were to remove all of my reflections completely, you can see that like our entire scene is completely bland. But if I were to go into my material, for example, and I were to set the metallicness to 0, you'll notice that the color is exactly the same. And that's because we're applying parameters such as metallicness and all that. So yeah, reflection probes are very, very important when wanting to create an accurate scene. However, in HDRP, we've added another one, and this is called a planar reflection probe. So instead of sampling in a sphere, so a 360 orb, a planar reflection probe simply samples from one direction. And we can see that on the floor here. So down here, if I can grab it, where is it? It's up here. Let's type in reflection. Here we go. So this is our planar reflection probe. So if I were to completely remove it, you'll notice that the floor is not looking as good anymore. If we were to go over to this section over here, if I turn it on and off, we're losing a lot of that visual fidelity by not having the planar reflection probe. So they're very, very useful to have if you're wanting to have a full-on flat surface and you want it to be slightly reflective. And now finally, I need to rush this bit. Finally, I'm going to create a refractive glass material. And this is going to allow you to basically warp light or refract it real time. So if I were to choose this panel back here, I'm going to select the shader, and I'm just going to create a new one. So this is just a blank shader that I'm just going to drag onto my object, and then we're going to start from scratch. So I'm not joking. It's like 2 minutes worth of work. It's so easy. So the first thing I need to do is determine my surface type. And I either have opaque or transparent. Now, this is super, super important for transparent objects, because if you try to set the alpha down to 0 with your surface type set to opaque, you're still not going to see through it because we're determining the surface of the object. So if I'm making a glass material, we're going to go transparent. I'm going to activate some displacement mode just to add a little bit of detail. And then I'm going to work my way down to my inputs, and I'm simply just going to turn my alpha all the way down. Next, I'm going to add a normal map. Oops. I'm going to add a normal map, and I'm going to put that up to something like 6 or something. I'm going to add my mask map, and then I'm finally going to add my height map. Again, we're going to be deforming these pixels. And before I do that, I just want to set the tiling to something a little bit more reasonable. So let's say 2.5. And then what I'm going to do is I'm just going to turn up the amplitude ever so slightly. And then because we've set our surface type to transparent, we have a couple of additional parameters down the bottom called transparency inputs. And this is where we can start to determine a refraction mode, or a refraction model, sorry. So if we select plane, nothing much happens just yet. And then if I were to start to warp it, you'll notice that my glass is now starting to look a little bit nicer. So again, this is incredibly hard to achieve, let alone, as an image, let alone real time and me just changing sliders, on the go. So I'm going to change my thickness down because my panel, I don't really think is that thick. And I'm just going to turn my refraction down a little bit. And you can see it's actually warping the background. So the light's going through the glass, it's bending, and then coming to the camera. So that's pretty much how easy it is to create realistic glass in HDRP. And I'm pretty much, so this is a very, very brief overview. I don't know if any of you attended the 45-minute version, which was kind of earlier this morning. I have a couple of blog posts and a couple of videos, and as well as a webinar, which can go over everything that I covered in a little bit more detail if you're interested in finding out more. And the London demo also is available for you to download. You can download the build, not the project, and you can have a little play around and see what we've done with it. And just to kind of show you on a final thought before I jump back to my slides, we can have a little walk around and actually experience what we've just done. So you can see here that I now have my glass that I've just made. We have our carpet. We have our lights. And again, the whole London demo is fully interactive, so we can kind of walk up to surfaces and start to play videos on our TV. And that's just a simple Unity component where I've dragged an MP4 into it, and now we can look at some awesome Unity content. And then finally, we've also added like a configurator as well, so we can kind of cycle through some different materials on the wood. So this is very much for a design visualization. But yeah, I think that's pretty much me done. I'm going to jump back to my PowerPoint real quick, or if I can get to it. So, additional information. If you want to find out more about the HDRP, then please follow some of these links. At the top is my blog post. This is Getting Started Guide for Artists. So I'm not segregating programmers. That's not what I'm doing. I'm just making it very general so everyone can kind of understand. Because sometimes the pipeline can be intimidating, so I wanted to kind of make it easier for everyone to understand it with me. And then, of course, we have the YouTube, the 3-part YouTube video equivalent of the blog post. The FPS sample project, you may have seen that dotted around. That's using HDRP2, as well as the Heretic and our previous cinematic, The Book of the Dead, which you can get from the Asset Store for free right now. And you can also download the FPS sample project from GitHub right now. And that's putting more into a game context rather than a visualization. Finally, Unity Learn Premium. We're actually doing a little special offer for our premium service of Unity Learn. For everyone that's at Copenhagen right now, you can get a 3-month free trial by using the code at the bottom, and you're going to gain access to non-gaming content at a beginner to intermediate level when wanting to work with visualizations like this, whether that's working with virtual reality, augmented reality, as well as some industrial ATM, as well as some AEC, so architecture and engineering construction content, available for you to download and have a try. So after all that, thank you so much. If you have any questions, I think I have like 5 minutes or something. So we're going to go with that. Hello, sir. Yep. Yeah, agreed. So I think I briefly heard you. I'm going to interpret that. So you're on about the range of a light. Right, right. It doesn't change from HDRP to built-in. With the standard, the range is just simply how far that light is going to reach before it starts to slowly fall off, and then it won't be there. So the range you pretty much have to balance with your intensity in your cookies, but the range is not influenced. The range doesn't have a value like a lumens or anything like that. That's just a thing that you have to figure out. Of course, you wouldn't want 2 lights overlapping on the same ranges, because that may cast dual shadows. So it's just kind of about balancing it. Yeah, come see me afterwards and we'll have a little bit more chat about it. Is that all right? Perfect. Oh, yeah. Hello.
Hi, Alessandro. Nice to meet you.
Nice to meet you.
So the problem is,
Yep.
when you put a light, in an offline renderer,
Yep.
you set only the intensity.
Yep.
Okay. And how far goes the light is because the intensity of the light.
Mm-hmm. Yep.
So if you scale your range
Yep.
for whatever reason or whatever parameter,
Yep.
and the intensity scale as well,
Mm-hmm.
it's not more physically correct.
That's correct. Yes. Yes.
So the question is, what is the value we have to keep in the range, and
Mm-hmm.
if we have to use the range to scale to not overlap the lights, how we have to multiply the intensity to compensate this?
Yeah, that's a good one. Yeah, come see me afterwards after this, and we'll discuss it more, because we have a booth over there which goes through the London demo, and we'll find out some more information for you. All right? Perfect. So that gentleman was basically asking about the range and intensity of lights and whether that will be physically accurate, affected by the range and all of that. If there are no more questions, you can... Oh, one more question. How many lighting probes? I can show you. If we were to go to, really quickly, so if I were to exit out, do you know about the lighting probe debug? Okay. So real quickly, I have 2 minutes. If you were to go to rendering lighting settings, and you were to go right down to the bottom to debug settings, light probe visualization, we can actually start to display weights for our light probes. So it's basically occluding, and we can see what light is being sampled via our light probes. So you brought up an interesting point about lighting and light probes, because light probes are a way of being able to mimic global illumination on non-static objects. Hence why we have more light probes around the door than anywhere else, because that door's moving. That door's not static. So it won't have global illumination calculated on it. So we have to sample it using the light probes and then share it with that mesh when that door opens. Otherwise, it's going to, in cartoons where that something's going to animate when it looks like slightly off, is exactly what it will look like. So this pretty much fixes that problem. But yeah, a reasonable amount of light probes, more on non-static objects. Does that make sense? Perfect. Yes, so to create a light probe, you go to down here, and then you can see a light probe group, and then you would just duplicate them across. It then samples so when you generate your lighting, those light probes absorb information and data, and then share that with any objects that are non-static and have a mesh renderer. Does that make sense? If you want to see me afterwards for more information, please do. Other than that, I'm going to leave it there. Yep, perfect. Thank you so much.